Hello everyone. In this video, I will cover the solution for assignment number 1 for the first module. At this assignment, you were asked to build the truth table and the timing diagram for certain circuits. Before I start talking about the assignment, I just want to talk about general information. When we having any logic gate or any circuit, we can describe this circuit in two different ways. The first one is the truth table. The second one is the timing diagram. The information in the timing diagram is exactly the same information in the truth table. But if I asked about truth table, I expect to see a truth table. If I'm asking about timing diagram, I expect to see timing diagram. For a truth table, we have to list the input in an alphabetic order. So we start, if I have A, B, C, I have to start with A, followed by B, followed by C. If I have X, Y, Z, I should start by X, then Y, then Z. And after that, I will list the name of the output. Maybe 1, maybe 2, whatever. I will list the output at the end of that table. For the combination of the inputs, we have to list them in an ascending order, which means I start with 0, followed by 1, followed by 2, followed by 3, which is 0, 0, 0, 1, 1, 0, and finally 1, 1. I left a notice for who didn't follow this strategy while they are building their own truth table. Make sure next time to put the inputs in an ascending order. For the OR gate, we figure out that if we have the inputs 0, 0, the output would be 0. Other than that, it should be 1. When I have AND gate, the output is 0 by default, unless all the inputs are 1. So I have two ones, the output is 1. If I have, for OR gate, two zeros, the output is 0. The inverter is just invert the value. So if I have 0, it will be 1. If I have 1, it will be 0. This is a truth table. In timing diagram, it's more casual. You don't have to list the input in certain order. That's fine. If you want to put it in order, that's fine. If not, that's okay. But you have to cover all the possible combinations. Since I have two inputs, I have 4 combinations, which is 2 to the power 2. So I have 0, 0, 1, 0, then 1, 1, then 0, 1. That's fine. You don't have to list them in the same order like we did in the truth tables. As far as we change the input, the corresponding output will change. So at this time, the value of x equals 0, the value of y equals 0, so x and y will be 0. And x or y should be also 0. The inverter here, the input is x, so I will invert the value of x, since the value of x at this time is 0, so I will make it 1. The value will remain stable until this time. At this age, I will start to change the input. Instead x being 0, I will make it 1. When I made x equal 1, I change the input, and the corresponding output will change too. So x and y still 0, because I still have this y equals 0. But for the OR gate, I figure out that the signal start to change. Instead of 0, it becomes to be 1. And it will be the case until a new change happen here for the value of y. The same for x dash, the value of x here is 1, so x dash should be 0. Once I change the value of x, the value of x dash start to change. And keep going for the whole input. Again, you have to cover all the different combinations of the input if you will represent the function or the circuit as a timing diagram. This is our assignment. By means of a timing diagram and the truth table, show the signals of the outputs F and G in the following figure as functions of the 3 inputs A, B, and C. I add a note here that little bubble after the AND gate, which is this one, and the OR gate, which is this one, is an inverter, which means not gate. So it means I have AND gate followed by not. I have OR gate followed by not. And I expect that all of you now are familiar with the name of these two gates. This one is an AND gate, and this one is an OR gate. We have here 3 inputs and 2 outputs. Let's start by building our truth table. Our truth table would be something like this. I list the input in an alphabetic order. The inputs are A, B, C, so I put A first, then B, then C. After that, I add the output. I have two output, this one, F and G, so I add F and I add G. I list all the possible combination of the inputs in an ascending order. So at the first one, I have 0, I have 1, I have 2, 3, 4, 5, 6, 7. What is the values I'm saying? This is the corresponding decimal values for these combinations. 0, 0, 0 is 0. 0, 0, 1 as a binary number. When I convert it to decimal, it should be 1. If you couldn't catch this, what is happening? For the least significant, we are alternating the value 0, 1, 0, 1, 0, 1. So it's changing every row. For the second one, we figure out that we have 2 zeros and 2 ones, 2 zeros and 2 ones, and we'll keep going. For the last one, we have 4 zeros and then 4 ones. If I have another input, most probably it will be 8 zeros and then 8 1. And I will keep the same pattern for the previous inputs. Here we have only 3 inputs, so I have 2 power 3 different combinations, which is 8 combination from 0 to 7 in decimal. And now we need to know what is the corresponding value of F, what is the corresponding value of G for all these inputs. Let's try this one first. When the input is A equals 0, B equals 0, C equals 0, they fit to this AND gate, 0 and 0 and 0, it should be 0. And we have a bubble, so we'll change this 0 to be 1. So the expected output for F from these inputs will be 1. What about G? If I have all zeros fit to an OR gate, I expect this is 0, this one is 0, this one is 0, so the output should be 0, and I have a bubble, so when I invert it, it would be 1. Let's go to the second combination of the inputs, 0, 0, 1. Since we have an AND gate, we can figure out that this AND gate, as far as I have 0 on it in the inputs, the output will be 0, and I have a bubble, so it will be 1. For the G, since I have 1 in the input and this is an OR gate, I expect that the output will be 1 and I will invert it because of this bubble, so the output would be 0. If you notice that, since we have an AND gate here, so whenever any of these inputs are 0, 0, it means the output will be 0. And I will invert it, so it will be 1. So whenever I figure out there is a 0, I expect to have 1 here. So I have 0 and 0, so here is 1. What about the OR gate? The OR gate is the opposite. As far as you have 1 in the input, I expect the output to be 1. And since I have bubble, or inverter, so this one will change to be 0. So I have 1 here, so this one should be 0. I have 0 here, this one should be 1. I have 1, so this one will be 0. And we'll keep going. I have zeros here, so the first one will be 1. I have 1, this should be 0. I have 0, this would be 1. I have 1, this should be 0. I have 0, this should be 1. I have 1, this should be 0. Let's look here. We have 1, 1, 1. We don't have any zeros at all, which means all the inputs here are 1s. And the output of this AND gate will be 1. And since I have an inverter, so I will invert it, it will be 0. So I expect to see 0 here, which is the case. And finally, we have 1, so the expected output will be 1, and they will invert it, so it will be 0. And this is the truth table for an AND and NOR gate that having a 3 inputs. Let's now think about the timing. diagram. Let's now think about the timing diagram. Again, you are not enforced to list the inputs in the same order or using ascending order for the combination of the inputs, but you are enforced to list all the combination. I don't care about the order, but I care about the existence of all the different combinations. To make it much easier, I will follow the same order of the truth table. So let's start with the first row. What we have here, the value of A is 0, which means I will have a low value or a low signal. Suppose that here is the low, here is the high signal. So A is 0, B is 0, 2, C is 0. So this is the values. What is the corresponding value of the output, which are F and G? F should be high, and G supposed to be high. So this is the first time. Let's try the next combinations. We have here 0, 0, 1. So I expect that the value of A will remain 0. So it will be still as it is. And for B, it will be 0. So it will remain 0. It is the same level. But for C, I will change it from 0 to 1. So we'll figure out that the signal will be high here. For F, it will remain as it is high. So I will just continue the line as straight as it is. And for G, it was 1, and I will make it 0. So I have to go down like this. And this is the time for the second row. This is the timing diagram so far. I cover the first combination and the second combination. Let's go to the third one. Figure out that the value of A here still 0. So I will remain at the same level. And for B, it will be 1, which means I need to raise this signal like this. For C, it's 0, so it will go down. For F and G, we figure out that F will remain 1 and G will remain 0. This is why I have the same signal so far. Let's go to the next combination. We have here 0, 1, 1, which means I will keep A at the same level. I will keep this one at the same level. But this one is 0 and I want to make it 1, so it will be 1. I will raise it to be 1. The output is 1 and 0, which means both will remain the same at the same line. Let's go to the next combination. We have 1, 0, 0, which means A should change from 0 to 1. I will change it. So I will go up like this. And for B, I will change it to be 0. So I will go down. For C, I will go down to make it 0. For F, it will remain the same, so I will just extend the line as a straight line. Let's go to the next combination. We have 1, 0, 1, 1. The inputs are 1, 0, 1, which means I will keep this 1 as it is. I will keep this 0 as it is. This 1 change, I have to change this 0 to 1, so I will raise the signal. And again, F and G will remain the same. This is F, this is G. The next combinations, we have 1, 1, 0. So I will keep this 1. This should be 1, so it's low. I will make it high. And this is high. I will make it low because it should be 0. And again, it will remain 1 and 0. So I still have 1 and have 0. Finally, this is the last combinations that I want to cover. I have an input here, which is 1, so it will remain 1. This one will remain 1. For this input C, it was 0, so it will be 1. And finally, the output F will change from 1 to 0. This is why it will go low. And finally, G will remain as this, so it will keep zeros. I hope now you understand what is going on and what is the difference between the timing diagram and the truth table. If you could focus more, you will figure out what I mentioned in the truth table. We will figure out that C is changing every time cycle. So it is low, high, low, high, low, high, low, high. Here it will remain for 2 cycles, then change. 2 cycles, then it change. 2 cycles, then it change. Here 4 cycles, then we will do a change. The main thing in doing a timing diagram is to make sure that you cover all the combinations. The easiest way to do that is to follow the same order of your truth table. So that's all I have for you in this video. I hope it makes the assignment clearer. And if you have any question, please let me know. See you.